All right, let's finish our 4.2 notes. And when we look at 4.2, what if our domain values are restricted? Normally, we're allowed to choose any value to plug in for x. I usually look for you to choose -2, -1, 0, 1, and 2. Those are the normal ones. But now we're going to have limitations on what we can choose. These limitations will be given as inequalities. It will mean that we will only be able to draw part of our line. So when we look at this problem A, y is equal to 3x minus 2, where the domain is x's are greater than or equal to 0. So when we go through this problem, the first thing we always check is, are we in function form or slope-intercept form? And yes, we are. We have y equals. So we can go ahead and choose our domain values that are greater than or equal to 0. So when we choose our domain values, we're going to choose 0 first, and then we're going to choose numbers that get bigger. So 1, 2, 3, and 4 are going to be those numbers that we're going to plug in. Plug the domain into the equation, so we're going to do 3 times 0 minus 2. 3 times 0 is 0, minus 2, so we have -2, which means that we'll graph the point 0, -2, and that will be our starting point. 0, -2 is our starting point. Go ahead and finish your table, and then tune me back in to finish our graph. Okay, let's finish this graph. We have our starting point of 0, -2. We need to plot the point 1, 1, the point 2, 4, and then we would plot the point 3, 7, and it's not on our graph. I'm going to approximate it. Remember, one of the things I said in our previous video was that sometimes in our table we'll have more values than we can actually fit on our graph paper. It's just to make sure that we know which way the graph is headed. So in this case, I was able to get bigger. I'm not allowed to get smaller, so my starting point being at 0, -2, and I'm allowed to have my x values go to the right. That's where they get bigger. And again, I should probably have used a straight edge when I drew that. But I cannot draw this left side, this where x values are negative. I'm not allowed to draw that part of the graph because my domain was restricted. It said that x's can't be negative. So when I look at the x-axis, I shouldn't have any points on the negative side of that. Let's go to problem B. In problem B, we're checking our function. Is it in function form? Y equals yes. My domain values now are set so that x's have to be between -2 and +3. So I'm going to start at -2, and the biggest x value I'm allowed to plug in is +3. I need to choose points that are in between there. -1, 0, and 1. I don't know if you have an extra space. It looks like I'm missing a piece of my table here. So if you have 5 spaces, do -2, -1, 0, 1, 2, and 3. So just plug your values in. We've gone over quite a bit about how to create this table. I'll do the first point again for you. So we plug our domain in. Our starting point was at -2 and add 2. So my starting point is the point -2, 0. And because I have both an upper and a lower limitation, then I also have a starting spot and an ending spot on my graph. so that 3 plus 2, which is 5, that point 3, 5 is my ending point. All the points in between are included, but this is my start, and that's my end. Because my domain is restricted, I cannot draw from edge to edge necessarily. I'm going to finish my table and then come back and finish the graph. Okay, we said that our starting point was at -2, 0, and our ending point is at 3, 5. I'm going to put in my other points, -1, 1, 0, 2, 1, 3, and maybe you put it on your table, so I'll put it on my graph, and 2, 4. So those are all the integer points on my graph. Don't forget that I also have decimal points. The ones that are in between, the ones that are in the spaces could also exist. And that this is the graph. It's limited. It has a beginning and an end. It's been restricted. Let's go ahead and do problem C together. Y is equal to 3. Y is equal to 3. The domain is x is less than or equal to 2. Well, the first thing that should stand out is that this y equal to 3 is a special case. It's not a sloped line. It happens to be a horizontal line, right? If the y value of every point is 3. The y value of every point is 3. And the x values are limited to being smaller or equal to 2. So the starting point is at 2. And these x values get smaller. I've got a few points I can graph. Notice that I skipped over this table altogether because I needed to think in my head. I wrote my ordered pairs over on the left, and I probably should put them in my table. So 2, 3 is this point. 1, 3, 0, 3. So my starting point is here, and my x values can get smaller. Means that my graph, in this case, goes to the left. It's restricted. It can't go to the right, but it can go to the left. Letter D is not a special case. Give it a try and see if you have the proper graph when you finish. Pause the video and give it a try. Hopefully you really paused it. Notice your ordered pairs. My starting point is at 0, 2. I have all of my other points. So here's my starting point, and then I head towards my other points. This graph has a starting point, but not an ending point. And apparently I've been sitting still too long, and that's the end of this video.